Hello and welcome. My name is Robert, and recently I started working on the CompTIA Pentest Plus path using the Tryhackme platform. Today I look to continue. I'm on Wireshark the basics. I've gone ahead and already reset this room. In my last video, I did the Metasploit introduction as I worked down tools and code analysis. I have completed planning and scoping, so I look to move through these rooms. I tried to record this video during the work week. However, I ran into some issues with the room and I didn't feel like troubleshooting it when I encountered those problems. So I waited for the weekend to have a little bit more patience and tried to tackle this now. I do think I understand what the problem was, so I'm going to cover that for you in case you encounter it, and I think this video will help. Task 1, Introduction. Wireshark is an open-source, cross-platform network packet analyzer tool capable of sniffing and investigating live traffic and inspecting packet captures, PCAP. It is commonly used as one of the best packet analysis tools. In this room, we will look at the basics of Wireshark and use it to perform fundamental packet analysis. Learning objectives. Navigate and configure Wireshark, inspect packets and discover information from the different layers of TCP/IP, and apply display filters. Prerequisites. The networking module, which I highly recommend if you're new to the platform. I believe that I've done it in the past. Environment setup. So here we're going to go ahead and start our machine, which is going to open in split screen view. And this is part of where I began to run into some of the issues that I experienced during the week. However, in just a little bit of messing around today, I think I understand the problem, and I think I can work through that now if it occurs again. Moving on while this loads, there are two capture files given in the VM. We can use the http1.pcapng file to simulate the actions shown in the screenshots. Please note that you need to use exercise.pcapng file to answer the questions. So it looks like it's coming up. And it doesn't look like I'm going to experience the problem now. However, if you have a problem and it fails to connect, if you just wait a little bit, it might actually connect. And part of the problem I ran into is I answered the questions. Oh, and we might see that now. And it started freaking out, but I think if I just stay in, the VM will stabilize. But we'll see. Let's work through this. And if I have a problem, I have a little bit more patience now on the weekend. Okay, answer the questions below. Which file is used to simulate the screenshot? http1.pcapng file to simulate the action shown in the screenshot. So that's going to be our first answer. Which file is used to answer the questions? And we have exercise.pcapng file to answer the questions. I have never completed this room, even as I had worked through it at whatever time in the past. And even recently, I only got through a couple of the questions. I think the most I've done of this room is about 63%, so I needed to complete this one anyway. Anyway, moving on. Task 2, Tool Overview. Use cases. Wireshark is one of the most potent traffic analyzer tools available in the wild. There are multiple purposes for its use. Detecting and troubleshooting network problems such as network load failure points and congestion, detecting security anomalies such as rogue hosts, abnormal port usage, and suspicious traffic, and then investigating and learning protocol details such as response codes and payload data. Note, Wireshark is not an intrusion detection system or IDS. It only allows analysts to discover and investigate the packets in depth. It also doesn't modify packets, it reads them. Hence, detecting any anomaly or network problem highly relies on the analyst's knowledge and investigation skills. GUI and data. The Wireshark GUI opens with a single all-in-one page, which helps users investigate the traffic in multiple ways. At first glance, 5 sections stand out. And these sections are going to be visually represented in this screenshot here, as it details right here. So, toolbar. The main toolbar contains multiple menus and shortcuts for packet sniffing and processing, including filtering, sorting, summarizing, exporting, and merging. Then we have the display filter bar. It's the main query and filtering section. Our recent files, list of the recently investigated files. You can recall listed files with a double click. And then we have the capture filter and interfaces. Capture filters and available sniffing points, network interfaces. The network interface is a connection between a computer and a network. The software connection, example like the LO, ETH0, ENS33, enables networking hardware. And then we have the status bar at the bottom there, which shows tool status, profile, and numeric packet information. Now we should open Wireshark, get it started, and the above picture shows Wireshark's empty interfaces. The only available information is the recently processed http1.pcap file. Let's load that file and see Wireshark's detailed packet presentation. Note that you can also use the file menu, dragging and dropping the file, or double-clicking on the file to load a PCAP. So we're going to just do it this way. Go to open. We're going to open http1.pcap and G, and as it says, there's multiple ways to do this, but we're going to just do it this way. Or maybe not. It doesn't look like it is opening. Can I double click it? Okay. Now we can see the process file name, detailed number of packets, and packet details. So pretty much everything we saw in this screenshot is now represented in our virtual machine. Packet details are shown in 3 different panes, which allow us to discover them in different formats. We have the packet list pane, packet details pane, and the packet bytes pane. So this is our packet list pane, packet details pane, packet bytes pane. So in our packet list, we have a summary of each packet, source and destination address, protocol, and packet info. You can click on the list to choose a packet to further investigate, as I'm doing here. Once you select a packet, the details will appear in the other panes. In our packet details pane, this one right here, this is the detailed protocol breakdown of selected packets. And then in the packet bytes pane, we have hex and decoded ASCII representation of the selected packet. It highlights the packet field depending on the click section in the details pane. So depending where we click, it's going to highlight. Oh, I think it's just at the high level. Okay. And you can see that it's highlighting the packet bytes pane where we click. And then we have coloring packets. Along with quick packet information, Wireshark also color packets in order of different conditions. And the protocol to spot anomalies in protocol in captures quickly. I apologize, that sentence just isn't reading well to me, and it might just be me. It's been a long week. This explains why almost everything is green in the given screenshot. But that makes sense, at least the green part. This glance at packet information can help track down exactly what you're looking for during analysis. You can create custom color rules to spot events of interest by using display filters. We will also cover them in the next room. Now let's focus on the defaults and understand how to view and use the represented data details. Wireshark has two types of packet coloring methods: temporary rules that are only available during a program session, and permanent rules that are saved under the preference file profile and available for the next program session. You can use the right-click menu or View Coloring Rules menu to create permanent coloring rules. The Coloring Packet link menu activates and deactivates the coloring rules. Temporary packet coloring is done with the right-click menu or View Conversation Filter menu, which is covered in Task 5. So that is View Coloring Rules right here. Or you can right-click. And we have, you can colorize the conversation, which is what that's walking us through. The default permanent coloring is shown below. So if we go to our coloring rules, go to View, and just go to our coloring rules, we could see those here. Traffic sniffing. You can use the blue shark button, which is this one here, to start sniffing and capturing traffic. The red button will stop the sniffing, and the green button will restart the sniffing process. The status bar will also provide the use sniffing interface and the number of collected packets. Then you can merge PCAP files. Wireshark can combine two PCAP files into one single file. You can use the file merge. Just look at where that is, file, and then right here. You can use the file merge menu path to merge a PCAP with the processed one. When you choose the second file, Wireshark will show the total number of packets in the selected file. Once you click open, it will merge the existing PCAP file with the chosen one and create a new PCAP file. Note that you need to save the merged PCAP file before working on it. And they actually have a GIF that demonstrates it. View file details, and there's another GIF. I'm going to open this one up as I read so that you can just watch that demonstration that they do. Knowing the details is helpful, especially when working with multiple PCAPs. Sometimes you will need to know and recall the file details: file hash, capture time, capture file comments, interface, and statistics to identify that file, classify and prioritize it. You can view the details by following statistics, capture file properties, or by clicking the PCAP icon located on the left bottom. Use the exercise.pcapng file to answer the questions. So we're going to actually switch now what file we're using. I'll open. And this says we want to use the exercise.pcapng file. Read the capture file comments. What is the flag? So to get to our comments, I think that was going here. Oh, it's right here. Read the capture file comments. What is the flag? Flag is Tryhackme Wireshark demo. We're gonna grab this. Okay, I just had to scroll down in the comments. It's right here. And let's open up our clipboard. We can grab that, throw that in, and answer that question. What is the total number of packets? Which that should show in our status bar down here. 58,620. What is the SHA-256 hash value of the captured file? Which I believe also is SHA-1, SHA-256. So we want to grab this here. Simple enough. Grab it out of our clipboard and put that in. Also, there is a hint for this one. File details can help. And that's going to conclude task 2. We can move on to task 3 here. Just close this out. Packet dissection. Packet dissection is also known as protocol dissection, which investigates packet details by decoding available protocols and fields. Wireshark supports a long list of protocols for dissection. And you can also write your dissection scripts. You can find out more about dissection here. Note, this section covers how Wireshark uses OSI layers to break down packets and how to use those layers for analysis. It is expected that you already have a background knowledge of the OSI model and how it works. If you need to learn more, you can Google the OSI model if it helps you visualize what we're talking about here. Packet details. You can click on a packet in the packet list pane to open its details. Double click will open details in a new window. Packets consist of 5 to 7 layers based on the OSI model. We will go over all of them in an HTTP packet from a sample capture. Picture below shows viewing packet number 27. Each time you click on a detail, it will be highlighted in the corresponding part of the packet bytes pane. Let's have a closer look at viewing the details pane. We can see 7 distinct layers in the packet. We have the frame packet, the frame and packet. We have the source MAC, the source IP, protocol, then we have protocol errors, and then we have the application protocol, and finally the application data. Below, we will go over the layers in more detail, and it looks like we can show an image on each one. So we have layer 1, the frame. Let's go ahead and highlight that here. So this is going to show us the frame packet you are looking at and details specific to the physical layer of the OSI model. Next, we have layer 2, the MAC, is showing us, this is from the data link layer of the OSI model. So if we open up Ethernet 2, and that is the data link layer of OSI. Next, we have layer 3, which is going to be the network layer of OSI, the Internet Protocol version 4. Go ahead and make that small. Open that up. So again, layer 3. Next, we have layer 4. This is going to show details of the protocol used for UDP and TCP, and source and destination ports from the transport layer of the OSI model. So let's go ahead and collapse that down. And it looks like we've got something sticky here. So transmission control protocol, again, that's going to be layer 4. Moving on, then we have our protocol errors. This continuation of the 4th layer allows specific segments from TCP that needed to be reassembled. And that's here, the 2 reassembled TCP segments. Next, we have the application protocol layer 5. Open that up. And this shows details specific to the protocols used, such as HTTP, FTP, and SMB from the application layer of the OSI model. Collapse that, and let's open Hypertext Transfer Protocol for you. Moving on, we have the application data. The extension of the fifth layer can show the application-specific data. And that is right here. Use the exercise.pcapng file to answer questions. View packet number 38. Which markup language is used under the HTTP protocol? So we want to go to packet 38, just scroll down to it. And that's going to be right down here. And we have extensible markup language. And we do have a hint. Packet numbers are shown. Also, it's telling you how to find that. Okay. What is the arrival date of the packet? Answer format, month, day, and year. We'll go ahead and take a look at the hint here. Packet details pane and frame section can help. What is the arrival? So I'm going to have to look around a little bit for this one. Arrival date of the packet. Oh, here we go. So it's under Hypertext Transfer Protocol. Last modified. I believe it's this one right here. Let's go ahead and put that in and see if that works. So we're going to do the month of May, the date of 13th, 2004. That was correct. What is the time to live value? Time to live, time to live, time to live. Or TTL. Don't see that in there. Go ahead and collapse these. Go to Ethernet. Frame. Time delta, time delta. Time shift. Oh, there's a hint. The packet details pane and IP protocol section. So time to live. 47. Tripped up a little bit on that one. What is the TCP payload size? Segment length. I believe that is it. And there is a, let's check it. Packet details pane and protocol section. I think 424 is the right answer. Let's go ahead and put it in. Yes, it is. Okay. What is the ETAG value? ETAG. Where would I find ETAG? ETAG value. Let's see. Oh, right here. So I think I could right click and copy. Copy value. Let's throw it in our clipboard. See if that works. There we go. Perfect. Okay, moving along. Let's go ahead and close this out a little. Get around. Okay, so that's gonna do it for task 3. We can move on here. Task 4, packet navigation. Packet numbers. Wireshark calculates the number of investigated packets and assigns a unique number for each packet. This helps the analysis process for big captures and makes it easy to go back to a specific point of an event. Go to packet. Packet numbers do not only help to count the total number of packets or make it easier to find and investigate specific packets. This feature not only navigates between packets up and down, it also provides in-frame packet tracking and finds the next packet in the particular part of the conversation. You can use the Go menu and the toolbar to view specific packets. As I read, this is going to be demonstrated in the pictures and the visuals below. So, find packets. Apart from the packet number, Wireshark can find packets by packet content. You can use the Edit, Find Packets menu to make a search inside the packets for a particular event of interest. This helps analysts and administrators to find specific intrusion patterns or failure traces. There are two crucial points in finding packets. The first is knowing the input type. This functionality accepts 4 types of inputs: display filter, hex, string, and regex. String and regex searches are the most commonly used search types. Searches are case sensitive, but you can set the case sensitivity in your search by clicking on the radio button. The second point is choosing the search field. You can conduct searches in the 3 panes: the packet list, packet details, and packet bytes, and it is important to know the available information in each pane to find an event of interest. For example, if you try to find the information available in the packet details pane and conduct the search in the packet list pane, Wireshark won't find it even if it exists. Then you can mark packets. Marking packets is another helpful functionality for analysts. You can point to a specific packet for further investigation by marking it. It helps analysts point to an event of interest or report particular packets from the capture. You can use the Edit or the right-click menu to mark or unmark packets. Marked packets will be shown in black regardless of the original color representation of that connection type. Note that marked packet information is renewed every file session. So, marked packets will be lost after closing the capture file. And then we have packet comments. Similar to packet marking, commenting is another helpful feature for analysts. You can add comments for particular packets that will help the further investigation or remind and point out important suspicious points for other layer analysts. Unlike packet marking, the comments can stay within the capture file and until the operator removes them. Export packets. Capture files can contain thousands of packets in a single file. As mentioned earlier, Wireshark is not an IDS, so sometimes it is necessary to separate specific packages from the file and dig deeper to resolve an incident. This functionality helps analysts share the only suspicious packages, decided scope. Thus, redundant information is not included in the analysis process. You can use the File menu to export packets. Next, we have Export Object Files. Wireshark can extract files transferred through the wire. For a security analyst, it is vital to discover shared files and save them for further investigation. Exporting objects are available only for selected protocol streams: DICOM, HTTP, IMF, SMB, and TFTP. The time display format. Wireshark lists the packets as they are captured, so investigating the default flow is not always the best option. By default, Wireshark shows time in seconds since beginning of the capture. The common usage is using the UTC time display format for a better view. You can use the View Time Display Format menu to change the time display format. And then we have Expert Info. Wireshark can also detect states of protocols to help analysts easily spot possible anomalies or problems. Note that these are only suggestions, and there is always a chance of having false positives or negatives. Expert Info can provide a group of categories in 3 different severities. Details are shown in the table below. So we have our severities, the color of them, and the info. We've got chat, note, warn, and error. Frequently encountered information groups are listed in the tables below. You can refer to the Wireshark's official documentation for more information on the expert information entries. And here it looks like we have 4 groups: checksum, comment, deprecated, and malformed. And then the explanation for those are the info for each. And we're at, we can answer these questions below. Okay, question number 1. Use the exercise.pkapng file to answer the questions. Search the raw string in packet details, or R4W. What is the name of artist number 1? So we wanted to go to view or edit, find packet. Okay, packet details. I think we want packet details, string. Maybe it needs to be case sensitive. Let's go ahead and throw it in and see if we could find that. Click find. Looks like it's loading. We get a status bar here at the bottom. We are able to find that artist. Let's copy the value. Let's see if we can extract that out of our clipboard. Looks like the value is right here. Throw that in and check. Next question, go to packet 12 and read the packet comments. What is the answer? Note, use MD5 sum, the file name, terminal command to get the MD5 hash. Let's check the hint. Use the right-click packet comments menu to view the comment. Make sure you scroll down to the end of the comment. So we're going to go to packet 12. Let's clear this, close this. We're going to go to packet. Packet 12. And what does it say? It says you can do, the hint says, use right-click packet comment. Right-click packet comment, there we go. Control-Alt-C is the quick key. And then it says scroll all the way down. Okay, go to packet number 39756. Look at the packet details pane, right-click on the JPEG section and export packet bytes. Let's just grab this text. Can I keep that in my clipboard? And will that stay in my clipboard? Okay, great. So 39765. Right-click on the JPEG section and export. Okay. Let's go to, I think it was 397. Why isn't that typing? 397. Okay. What? I don't know why this is messing up. Maybe there's a lot of white space in there. 39765. Go to packet. Oh, okay. So we have the JPEG. What do we do with it? Right click on the JPEG section and export packet bytes. Okay. Right click on it. Export the packet bytes. We can save it into our downloads and we'll save it as JPEG.file. Save it. And then oh, that saved it in my VM. I almost launched my terminal on my my desktop. It's hilarious. So I saved it into downloads. Now we need to navigate to downloads. Maybe we could just open up the terminal, make it easy. Close out this window. ls cd to downloads. ls, and then we want to do md5 sum jpeg.file. It's going to give us this. Should be our md5. Yeah, it's our MD5 hash. Just making sure what I had to do for this question. Pull that in, put that down. All right. Next, there's a .text file inside the capture file. Find the file and read it. What is the alien's name? Let's go ahead and just close our terminal here. I don't think I need that again. Get Wireshark right over here. Okay, so there's a .text file inside the capture file. You don't remember how to output the files, but I know it tells us above how to do that. Display format, export. Oh, maybe we can. Do we want to export the file for this one? Let's look. Just text. Does it tell us how to search for the text file? Packet comments, mark packets, find packets. Packet number search, go to a packet. Packet comments, export packets. I think this is what we want to do here. So we go to file. So if we export objects, HTTP maybe. File name. I don't see any. Oh, there we go, right there. Okay. What do we want to do with it? Text file inside the capture. Find the file and read it. What is the alien's name? So can I just export the one file, or is it gonna do? It's gonna do all of these, isn't it? I don't want to do that. There's got to be a way to just export specific packets. Oh. Nope, that exports. That's not what we want either. Maybe a dissection is plain text. I'm thinking there's got to be a way. Let's just try highlighting this. Text filter. Oh, that's perfect. So in the text filter, if you just do the file extension, you get the file that you want, then you can save it. And we're going to save that into our downloads folder as note.txt. Close this out. And then we want to read it. Downloads. Let's open up our note.txt. We've got our alien. And we've got the name. Can I zoom out of that? So it's good. This looks like it is longer. I don't know if that's really it. It must be, right? Let's go ahead and, what is that? PAC, packet master. Oh, that does fit. Maybe it's just an illusion by the way I look at the text. And again, I apologize. I've had got a lot of other things on my mind. So That works. Okay, packet master. Look at the expert info section. What is the number of warnings? Don't really remember what that's calling for here. Oh, it does give a count. Okay, 1636 or 1636. Okay, great. That in, that'll conclude that. So we finished task 4, on to task 5. Task 5, packet filtering. Wireshark has a powerful filter engine that helps analysts to narrow down the traffic and focus on the event of interest. Wireshark has 2 types of filtering approaches: capture and display filters. Capture filters are used for capturing only the packets valid for the used filter. Display filters are used for viewing the packets valid for the used filter. We will discuss these filters' differences and advantages and advanced usage in the next room. Now let's focus on the basic usage of display filters, which will help analysts in the first place. Filters are specific queries designed for protocols available in Wireshark's official protocol reference. While the filters are the only option to investigate the event of interest, there are 2 different ways to filter traffic and remove the noise from capture files. The first one uses queries, and the second uses the right-click menu. Wireshark provides powerful GUI, and there is a golden rule for analysts who don't want to write queries for the basic tasks. If you can click on it, you can filter and copy it. Apply as filter. This is the most basic way of filtering traffic. While investigating a capture file, you can click on the field you want to filter and use the right-click menu or Analyze Apply as Filter menu to filter the specific value. Once you apply the filter, Wireshark will generate the required filter query, apply it, show the packets according to your choice, and hide the unselected packets from the packet list pane. Note that the number of total displayed packets are always shown on the status bar. Then you have a conversation filter. When you use the Apply as Filter option, you will filter only a single entity of the packet. The option is a good way of investigating a particular value in packets. However, suppose you want to investigate a specific packet number and all linked packets by focusing on IP addresses and port numbers. In that case, the conversation filter option helps you view only the related packets and hide the rest of the packets easily. You can use the right-click menu or Analyze Conversation Filter menu to filter the conversation. Next, we have Colorize Conversation. This option is similar to the conversation filter with one difference. It highlights the linked packets without applying a display filter and decreasing the number of viewed packets, the viewed packets. This option works with the coloring rules option, add change that packet colors without considering the previous applied color rule. You can use the right-click menu or View Colorize Conversation menu to colorize a linked packet in a single click. Note that you can use the View Colorize Conversation Reset Colorization menu to undo this operation. Next, we have Prepare as Filter. Similar to Apply as Filter, this option helps analysts create display filters using the right-click menu. However, unlike the previous one, this model doesn't apply the filters after the choice. It adds the required query to the pane and waits for the execution command, or enter, or another chosen filtering option by using the and/or from the right-click menu. Next, we have Apply as Column. By default, the packet list pane provides basic information about each packet. You can use the right-click menu or Analyze Apply as a Column menu to add columns to the packet list pane. Once you click on a value and apply it as a column, it will be visible on the packet list pane. This function helps analysts examine the appearance of a specific value field across the available packets in the capture file. You can enable or disable those columns shown in the packet list pane by clicking on the top of the packet list pane. Follow stream. Wireshark displays everything in a packet portion size. However, it is possible to reconstruct the streams and view the raw traffic as it is presented at the application level. Following the protocol stream helps analysts recreate the application level data and understand the event of interest. It is also possible to view an unencrypted protocol data like usernames, passwords, and other transferred data. You can use the right-click menu or Analyze, follow TCP, UDP, HTTP stream menu to follow the traffic stream. Streams are shown in a separate dialog box. Packets originating from the server are highlighted with blue, and those originating from the client are highlighted with red. Once you follow a stream, Wireshark automatically creates and applies the required filter to view the specific stream. Remember, once a filter is applied, the number of the viewed packets will change. You will need to use the X button located at the upper right side of the display filter to remove the display filter and view all available packets in the capture file. Now we're on to our questions. First question is, use the exercise.pcapng file to answer the questions. Go to packet number 4, right-click on the hypertext transfer protocol and apply it as a filter. Now look at the filter pane. What is the filter query? Let's just jump in. We're going to go to packet, and it wants us to go to packet number 4. Having a problem with that. Just had to backspace and get the white space out. Go to packet. So I want packet 4, and then it's telling us to right click and apply as a filter. The selected. Okay. Frame time. Did I do that wrong? So let's go ahead and exit that filter. So go to packet 4, right click on, that's where I messed up. So we need to go to HTTP, make sure we hover over that and apply as filter. No, am I wrong? Packet 4, can't apply it as the filter. Why not? What did I do here? Text protocol. Oh, do I need to do it here? Maybe I need to do it down below. That's what I messed up on. Okay, so you had to do it in the details. Okay, makes sense. HTTP. Let's go ahead and put that in. Looks right. What is the number of displayed packets? It looks like it's 5,800 or 58,620. Oh, displayed. It's the one next to it, right? 1,089. Okay. Go to packet 33790, follow the HTTP stream. See. Oh, so it's where I click in here is why I get the white space. Good to know. I'm figuring it out. 33790. Let's go to that packet. And then we need to follow the HTTP stream. So I'm going to right click on it. Follow. And it said to do the HTTP stream. Looking at the web server's response, what is the total number of artists? So we can find artist, find next. So we've got our artist reference. Artists, maybe they're right under here. No. Artists. Looks like there's a lot of references to artists. So how can we do this? Artist equals 1. Artist equals 1. So it looks like it's listed. So do we get the name of the artist? Maybe we can use artists. Let's do 0 through 9. See if this works. Plus at the end. Can we find that way or no? So it looks like there's 6. Maybe 6 references to it. Let's go ahead and throw that in. That is not the right answer. So we know that artist equals 1. We get artist number 1. Artist equals 1. Maybe they're all listed here. Artist equals artist 2, artist 3. Okay. And then I can iterate through these. Looks like there was just 3. Okay, looks like there's 3. That is the correct answer. And what is the name of the second artist? Artist equals 2. Blade. Let's grab that. Copy. Looks like I grabbed an extra character there. Control C. Control 3. Pull that in. All right, done with task 5. On to task 6. Congratulations, you just finished the Wireshark, the basics room. In this room, we covered Wireshark, what it is, how it operates, and how to use it to investigate traffic captures. Want to learn more? We invite you to complete Wireshark Packet Operations Room to improve your Wireshark skills by investigating packets in depth. I probably haven't done this room yet, but I probably will at some point. So that has, well, it's showing 94% because I haven't completed the check. And we've completed the room. I'm going to go ahead and close this out. Terminate our box. And I've finally completed Wireshark the basics. That took a little bit of a delay. I expected that to come up sooner. So continue, continue. 9 days in a row, continue. All right, in the next video, we're going to look at Burp Suite. Thank you for watching, and I truly hope you enjoyed.